All right, here we go with our last paper problem. This is from paper 3. Now we have this person here spinning around on this. It's supposed to be a ride, the spinning circular room thing where the floor drops out. And I will actually, what I want to do is I want to draw a free body diagram of this person right away. Again, I haven't read this question yet. Just this is my experience. So I'm going to draw them as a dot. And what we're basically going to say is that we have a reaction. We're going to have the friction force holding them up and keeping them from sliding downwards. There's their weight force, and then there's the reaction force from the wall pushing them inwards, and that's what accelerates them in the circle. So let me actually write down the forces that are acting. So we've got friction and weight pointing down. These two forces ought to balance so that she doesn't fall. Okay. That's just my impression here. I haven't read the question yet, but I've just done this problem a few times, and this is kind of how it is. And then we have the reaction force making her accelerate in a circle. I'm assuming it's a her. Why not? And so we're going to say v squared over r, and it's like that. All right, so we're going to go ahead now, and we're going to define the coefficient of friction. And what we'll start with is the IB formula. F is, so the force of friction is mu times the reaction force. And just to be clear, this is the ratio between the friction force and the reaction force that helps produce the friction. It measures the stickiness of the surface. Okay, that's how I'd want to say this. Here we go. Yeah. All right. Now for here, this is static friction, and the reason we know that is this is static friction. And the reason we know that, holding the person up, because we know they are not moving vertically. Okay, and that's really what this is about. Yeah. Now for part C. All right, that's so funny because this is exactly the free body diagram we drew. I swear I didn't read the question, so let's just draw it. Here we go. So we've got, the force of friction, we've got the gravity force, and we've got the reaction force there. All right. So let's get the magnitude of the horizontal resultant force on the person. So we know that R is m times v squared divided by the radius. So that's going to be 80 times, now do we have a speed? Did they give us a speed? Well, so we will say v squared divided by r, which is 6. And it says the magnitude of the minimum resultant horizontal force. Looks to me like I'm going to have to solve this part down here first. So it says the minimum speed will allow for a person to be stuck to it. So I know that the weight force equals the friction force, which is mu times r. So I know that 80 times 10 equals 0.4 times this reaction force, which is going to be 80 times v squared divided by 6. So the 80 cancels. I'm going to end up getting 60 divided by 0.4 is v squared. And so when I isolate V, I'm going to get 12.2. But we can go to 2 sig figs, so I'll say 12 meters per second squared. And then since this V squared, I actually got it as 150 when I looked at V squared, I can get R now as 80 times 150 divided by 6. So 150 divided by 6, that's 2 times 6 is 12, so it's 30 times 5. 80 times 25 is going to be 2,000 newtons of force. All right, so that is it for the practice exam. And I'm going to put a second practice exam up if you want to study a little bit more later.